This is the first section for section 3.3, and there are no formal notes in your note packet for what we're going to discuss today. I just need your undivided attention, and since it's a video, it would be hard for you to participate. But we're just going to go through a couple of slides, and that'll help explain the homework for this day in section 3.3. You still don't need your technology. You just also don't need to really have your notes out. So we're starting to talk about differentiation. And when we say differentiation, what we really mean is finding the derivative. And we know that we can use the limit method to find the derivative. It just so happens, though, that limit method is pretty cumbersome. So let's just kind of go back to what we know about differentiation. The essential question is, what patterns do we see in the limit method so that we can make shortcuts? And we'll get into that essential question on the second day of the section. So when I say derivative, you should be thinking slope. And so if the derivative of a function is its slope, then for a constant function, let's think about what the derivative must be. So if we think about a constant function would be a horizontal line. So that derivative must be 0. So here's that constant function. And so if the derivative is its slope, then the slope of this has got to be 0. So we can kind of note that by saying the derivative, y prime, that's one of our notations for the derivative. Y prime has got to equal the slope. The slope of this function is 0. So what we can say then is the derivative of a constant. So that's how we write that. The derivative of a constant is 0. So we can say that, saying that is the derivative of some constant function equals 0. So let's get some examples of constant functions here. F of x equals 5, or we could say y equals 5. So f of x equals 5 looks like that. And if we think about the slope of this, the slope of the function is 0. So when I say slope, you should be thinking derivative. So that means the derivative must equal 0. Let's take a look at another constant function, g of x equals 1. So here's the function g of x equals 1. Looking at that function, we see that the slope everywhere is 0. So we can say that the derivative of g of x, g prime of x, equals 0. Let's take a look at another constant function, h of x equals -2. So if we look at this constant function, h of x equals -2, we look at the slope of this function, the slope everywhere on h of x is 0. So since slope and derivative mean the same thing, then we can say the derivative of h of x is 0. So we're just looking at the value of those slopes to determine our derivative. And that's easy enough to do, especially when the function is constant. So can you think of other functions that have constant slope other than the horizontal lines? And so if you think about that, we also can deal with lines that aren't horizontal. They still have constant slope. So if we look at this line here, f of x equals 5x plus 0. I'm going to have to move that over a little bit. That should be having an intercept of 0. So what is the slope of f of x? Well, the slope of f of x is 5, which means the derivative everywhere must be 5. Looking at another one, here's g of x with a slope of 1 and an intercept of -2. So an intercept of -2 and a slope of up 1 over 1. So what's the slope here? The slope of g of x is 1, which means the derivative of g of x must be 1. Let's take a look at another linear function. Here's h of x is -2 plus 4. So we have an intercept of 4, and then we go down to that right 1, down to right 1. So the slope of this function is -2. which means the derivative of that function everywhere is -2. So as long as the slopes are constant, in other words, as long as the slopes never change, then we know the derivative everywhere is going to be that value of the slope. So those two examples, like a constant function and a linear function, they're easy to find the slopes, and so it's easy to determine the derivative. We don't really need the limit method. But when we start talking about higher order polynomials, so when we start talking about x squareds or x cubes, and start talking about what the slope is, we can see that since this function has some hills and valleys, and it increases in spots and decreases in other spots, that the slopes or the steepness of this function changes depending upon where you are. So at this point, to talk about the slope, we got to be really specific if we want to put a value to it. So now we need to start using that limit method to find the derivative. So we can get an expression by doing the limit method, but if we want a value, a numeric value, a steepness, then we have to really look at the specific location that we're talking about. So we're going to use that limit method, which I know you're really super enthusiastic about. And we're going to use that limit to find this expression, that limit method, just a few more times to find that expression. But the steepness of this function depends upon where we are. So we're going to go through the limit method for this function, x squared plus 5, as an example, so that you can work through the homework problems a little quicker. So if we graph this, we know it's a parabola. You see the x squared, and we have an offset of 5, so it's up 5 units. And if we need to do the limit method on this, since we don't have a constant slope, just a reminder of the limit method here, which means we have to get expressions for f of x plus h and f of x. So we'll start with f of x. So f of x is just the function itself, x squared plus 5. F of x plus h means put x plus h everywhere you see an x. So we have x plus h quantity squared plus 5. And we need to FOIL that out. So FOILing this out gives us our x squared plus our 2xh plus our h squared plus 5. So we know that this expression and this expression go in the top of the fraction here. So kind of mapping this out, here's our fraction. We have the limit as h approaches 0, which is this. Now we're going to put f of x plus h here. So we're going to take this and stick it here. And then we have our f of x, which is this, and we're going to put that here. And then we're going to divide by h. So we have to simplify this top first before we do anything else. So the first thing we're going to do then is distribute this minus sign. So if we distribute this minus sign, everything in here becomes negative, and then this becomes a plus sign out here. Now we can start canceling. We have an x squared and a negative x squared. Those are going to cancel out. We have a 5 and a negative 5. Those are going to cancel out. So what are we left with on the top? We're left with this, 2xh plus h squared. And then on the bottom, we have our h. So once if you notice, all the non-h terms, in other words, all the terms that don't have h's, canceled out. And that's by design. You know you've done this correctly when that happens. And it has to happen. We have to be left with the h terms so that we can do our factoring out of an h and our canceling, so that we can get rid of that fraction. Now we're left with the expression 2x plus h. And we can plug in 0 now. That's okay mathematically. So our derivative for the function x squared plus 5 is 2x. So this itself, 2x, is a function. So when we take derivatives of functions, we get other functions. So 2x looks like an intercept of 0 and a slope of 2. So that's the limit method, and that's going to be similar to what you're going to need to do for the homework. The homework is in your email, and it's 8 questions. And what we're going to do is you're going to be responsible for doing questions 1 through 4 on your own. And then questions 5, 6, and 7, 8. So 5, 6, 7, and 8, you're going to be assigned one of those. And you're going to do an anchor chart for this, finding the derivative of the function that your group is assigned. So the example of the x squared plus 5 is going to serve kind of as your template for doing these more complicated functions, and I'll put that in class. We'll get that back up on the board so that you can see that. So in your email I sent you a link, and so if you're in class you're going to be doing that anchor chart with your assigned problem, so you're going to have to pick up some graph paper and annotate it so that it can be a useful study guide for us. And once you get that done, then you can go back and do questions 1 through 4 in that homework. So that homework, like I said, it's in your email. You are responsible for 1 through 4 on your own, and then your group is responsible for either 5, 6, 7, or 8, depending upon which card you pick up. And that is your day 1 homework. There is no web assign.